To add or subtract rational expressions, the basic rules are the same as what you have to do to add and subtract fractions. So first we need to find the lowest common denominator. And if we think about that prime factorization method, 7x is just 7 times x. And x squared is x times x. So we take 7 from there. We take x from both of them. And then another x left over makes this an x squared. 7x squared is the lowest common denominator. So then we need to change the denominators into 7x squared. What do I have to multiply 7x by? By x, right. So this first one is going to be, it's 1 times x. And the second one, what do I have to multiply it by? 7, right. So this is going to be 1 times 7. You don't necessarily need to write out that step, but just to show you where these numbers are coming from. The original numerator multiplied by whatever you need to change the denominator. So we're multiplying the first one by x over x, the second one by 7 over 7, and we end up with x plus 7 over 7x squared. Can that be simplified? No, no common factors, right? So that one's done, except we still need non-permissible values. X cannot equal 0. So these are more like the rational expressions we've been working with, but I also did put the instructions there on the side. Find a common denominator by factoring the denominators. So this is where that prime factorization comes in. That's what we were doing with fractions, finding the prime factorization. We're going to do that here as well. No need to factor the numerators like you were when you were multiplying and dividing. We'll leave the numerators as they are. So 2x plus 2, but factor the denominator. So the first denominator factors to x plus 6 and x minus 2. The second one is a difference of squares. So x plus 2, x minus 2. That's going to be the first step. If you notice that the numerator can be factored, it might be useful to do it sometimes. But really only if there's a common factor in the numerator and the denominator. And there wouldn't be here, so I'm just going to leave the numerators. But the denominators become x plus 6 times x minus 2 and x plus 2 times x minus 2. And those are the prime factorizations. To find the lowest common denominator, we're going to take each factor from the prime factorizations of the denominators, the same as we did with when we were just doing numbers. So we'll take the x plus 6 as part of the lowest common denominator. And it's just here, so we'll take that one. We'll take the x minus 2, but it's in both spots, right? That means we just put one of them, though. And then there's the x plus 2 that's still there. So we don't need to include the x minus 2 twice. It's in both spots. We only need to include it once. The only way we'd need to include 2 of them is if there were 2 of the same factor in one of the fractions. So x plus 6, x minus 2, x plus 2 is the lowest common denominator. And then we need to figure out what do we have to multiply by. It says multiply each fraction to make equivalent fractions with the LCD, which stands for lowest common denominator, as the denominator. So we want to take this fraction that has x plus 6 times x minus 2 on the bottom and change that bottom to x plus 6, x minus 2, x plus 2. Which means that we need to multiply it by x plus 2. So what we're multiplying here is x plus 2 over x plus 2, because when you do that, the denominator will become x plus 6, x minus 2, x plus 2. So I'm just going to write that here. 2x plus 2 has to multiply by x plus 2. What does the second fraction have to multiply by? X plus 6. Because it's already x plus 2 times x minus 2. We need to change it to x plus 2 times x minus 2 times x plus 6. So this one's going to multiply by x plus 6 and x plus 6. So this becomes minus x plus 1 times x plus 6. Next step, expand the numerator and simplify. So this is where we hope that you're pretty good at algebra, because these have a lot of algebraic simplifications to go through. There's lots of factoring, and then there's also lots of expanding and simplifying. So I'm going to do 2x plus 2 times x plus 2. That's two binomials. I need to use the distributive property. So I'll go 2x squared plus 4x plus 2x plus 4. That's just these, right? I did 2x times x to get 2x squared, 2x times 2 to get 4x, 2 times x, and 2 times 2. Then I need to do the same with the other two binomials, minus, and I'm going to leave it in a bracket just to show that that negative goes with the entire second set of binomials. So we'll do x times x is x squared, x times 6 is 6x, 1 times x is x, and 1 times 6 is 6. And that's a really big numerator. And then I have to rewrite that denominator. And some of you are going to hate doing that, but I'm going to be really particular on this one thing. The reason is, if I just include the numerator, then when I'm saying this is equal to the row above, it's not actually equal to the row above. You need to write down that denominator every time. Now I need to combine terms. So I have 2x squared minus x squared. So altogether that leaves me with x squared. And then I have 4x, 2x, minus 6x, and minus x. So that's negative x. And then I have 4 and negative 6. So negative 2. X plus 6. I'm running out of space here. Still over that whole denominator. At this point, it would be a good idea to look at the answer and see if you can simplify it. Sometimes you're finished at this point. Sometimes you can factor the numerator, and if you can, you should. So that numerator will factor to x minus 2 and x plus 1. Anybody see why that was an important step? Yeah, because now you can simplify it further, right? Yeah, there's an x minus 2 on the top and an x minus 2 on the bottom. So we can cancel them out, because now everything is just factors. Now we can start to cancel. That's actually not that common to have a factor that will cancel like that, but it does happen. It's not really that common. Okay, so now we're left with x plus 1 over x plus 6 times x plus 2. And x cannot equal negative 6 and positive and negative 2. You're gonna miss the whole. Step 1 is factor the denominators. So this is x plus 4 and x plus 5? Yeah. Okay. And the other one, x plus 4, x plus 3. So then the common denominator, x plus 4, that's in both denominators. We just use it once. X plus 5 and x plus 3. Now, what does the first term have to multiply by? All of those? Nope. The missing one, right? And what's the missing one? X plus 3. Yeah. The first one has to multiply by x plus 3. Because the denominator already has x plus 4 in it, it has x plus 5 in it, it's missing x plus 3. So that's what we have to multiply this denominator by to change it into this one. So the other one already has x plus 4, and it has x plus 3, so it has to multiply by x plus 5, right. This one's actually a little easier than the previous one. Although we'll see how it turns out in the end. All right, so the next step is simplify the numerator. We'll go x times x is x squared, x times 3 is 3x, negative 4 times x, and negative 4 times 5. And I'll rewrite that whole denominator. Simplify the numerator. X squared minus x minus 20. Can this be simplified further? Yes, because the numerator can be factored. And the numerator is x minus 5 times x plus 4. And then what? You can cancel out and reduce by x plus 4. I did say that it's not very common that that happens, but then both examples I gave you, it did happen. But it actually isn't that common that it happens. It happened to be in both of these examples, but most often you won't have anything that can cancel at this point. Just like most often, if you find actually the lowest common denominator when you're adding or subtracting fractions, you can't reduce at the end. Sometimes you can, but usually not.
Can you factor out a negative 1?
X cannot equal negative 4, negative 5, and negative 3.